In this class, we are going to see about comparison of half wave rectifier, full wave rectifier, and bridge rectifier. Later on, we will go to the voltage regulator concept. In voltage regulator concept, we are going to use a GNR diode. In the GNR diode, we are going to place that GNR diode in the parallel format. We can call that GNR diode placed in the parallel format shunt. Shunt, we can call that it as shunt GNR voltage regulator. We are going to analyze for this class. Please tell me whether my screen is visible or not. Is it visible, students?
Yes, sir.
Okay, right. This is the comparison. Please try to write this one. Try to write this one. It is beneficial to you in the external point of view as well as internal point of view. This comparison table is so important. You can easily memorize all the terms at a time. That is the point here. And first one is IDC or I average value. We have derived in the derivation part, analysis part. IDC or I average value in the half wave rectifier, it is Im by pi. In the full wave rectifier, it is going to be 2Im by pi. 2Im by pi. That is the conduction state. Initially, the conduction state is conduction current is Im in half wave rectifier, whereas in full wave rectifier 2Im. That is Im by pi in half wave rectifier, 2Im by pi in full wave rectifier. Bridge rectifier, it is 2Im by pi. And next one is RMS value or AC value, IAC value or IRMS value. It is given by, in half wave rectifier it is Im by 2, whereas in full wave rectifier it is Im by root 2. In bridge rectifier it is same as full wave rectifier, that is Im by root 2. And next one is VDC value. VDC value same as IDC, like that. That is VDC is equal to Vm by pi. Here 2 Vm by pi. Here bridge rectifier 2 Vm by pi. Next parameter is percentage efficiency. In the half wave rectifier, that is 40.6%, whereas in full wave rectifier it is 81.2%, whereas in bridge rectifier it is efficiency is 81.2%. And ripple factor of half wave rectifier is 1.21, that is 121%. In full wave rectifier, that is ripple factor is 0.482, whereas in bridge rectifier it is same as 0.482. Ripple factor is in half wave is 1.21. This is get reduced it is get reduced in the half wave rectifier as well as in bridge rectifier. Next, ripple factor frequency. Ripple factor frequency is given by, in half wave rectifier it is f, whereas in full wave rectifier it is 2f, whereas in bridge rectifier it is 3f. 3f, it is like that. We are going to given here with respect to the ripple factor. Next, peak inverse voltage. Peak inverse voltage, maximum voltage is Vm. Here 2 Vm, whereas in bridge rectifier each and every diode I am considering in the reverse bias condition, that is given as Vm here. Single diode, only single diode, that is maximum voltage is Vm. Next, transformer utilization factor tough. Transformer utilization factor tough in half wave rectifier is 0.286, whereas in full wave rectifier it is 0.693, whereas in bridge rectifier that is 0.812. In terms of percentages, I can read that it as 81.6%, 69.3%. This is 81.2%, like this. And next parameter is number of diodes we are using in half wave rectifier is 1, whereas in full wave rectifier it is 2, whereas in bridge rectifier it is 4. Types of transformer. What is the type of transformer we are using here means, in half wave rectifier and bridge rectifier it is same, step down transformer, whereas difference is, in full wave rectifier we are using center tapped step down transformer. We are going to use center tapped step down transformer. The basic difference is this one, center tapped step down transformer. Here the cost for construction of these different circuits, for half wave rectifier only small component, only little components I are going to use here. Very small amount of components I am going to use here, therefore its complexity is less, therefore cost is also less here. Whereas in full wave rectifier its cost is high. Bridge rectifier it is very much high compared to full wave rectifier. Next, advantage and disadvantage. It is just like a comment. Here in this half wave rectifier, its ripple factor is very high, requires only one diode. It requires only one diode. This is the disadvantage is its ripple factor is very high. Advantage is it requires only one diode. Next one is with respect to full wave rectifier, peak inverse voltage is high. Peak inverse voltage is 2 vm, it is high. And advantage is ripple factor is low. Ripple factor is low here, that is 0.48. 0.48. Whereas here, next under bridge rectifier, peak inverse voltage and ripple factor both are low here. Peak inverse voltage as well as ripple factor, these two are low. Low here. These two, ripple factor as well as peak inverse voltage, these two factors, peak inverse voltage as well as ripple factor, these two factors are low and requires, and one of the disadvantages, it requires more number of diodes, that is it requires 4 diodes. This is the basic difference between half wave rectifier, full wave rectifier and bridge rectifier. We need to derive the main, all these parameters are very important in your exam. They may ask first 6 parameters, like that they may ask all the parameters, they don't ask. They, in this 8 parameters, they may ask any 5 or 6 parameters, they will ask in your examination, in internal as well as in external also. Okay, but you are supposed to know each and every parameter. Okay, here we are not provided any form factor and peak factor also. It is very beneficial to write form factor and peak factor also here. ఫామ్ ఫ్యాక్టర్ పీక్ ఫ్యాక్టర్ కూడా రాస్తే మంచిది అనమాట. ఇక్కడ అది కూడా రాసుకోండమ్మా మీరు, ఒకవేళ ఇప్పుడు రాస్తూ ఉంటే అవి కూడా ఇంక్లూడ్ చేస్తే బెటర్. ఓకే, దిస్ ఈస్ అబౌట్ కంపారిజన్ ఆఫ్ త్రీ సర్క్యూట్స్. నెక్స్ట్, voltage regulators. Next concept is voltage regulators. Voltage regulator means simply let it be, this is the, let it be, this is the waveform. This is the waveform. It is maintaining some constant voltage 5 volts, 5 volts with respect to time. I am getting some constant output voltage V naught, like this. Maintaining the output voltage constant, then we can call that it as a voltage regulator. Here voltage is regulated, this voltage is going to be regulated at some fixed amount of voltage, that is known as simply electronic voltage regulator. Here in an electronic circuit that maintains nearly constant output voltage, some constant output voltage is maintained, that is, let it be some 5 volts or 10 volts or 15 volts, like that we are going to maintain. But in practice, the output voltage of an unregulated power supply varies due to the following reasons anamata. That is, the output voltage of an unregulated, that means unregulated power supply. Regulated power supply, in regulated power supply we can maintain the constant output voltage, but with respect to the unregulated power supplies, we can't make any sort of constant output voltage in this type of power supplies. The main causes for this unregulated power supply, what is the parameters are going to be varied, means change in input voltage. By changing this input voltage, output voltage will vary. And next one is change in load resistance, change in V in, change in input voltage, change in input voltage, change in load resistance, change in load resistance, and change in temperature. Change in temperature. These are the parameters. The variation in the output may takes place due to the change in the input voltage, due to the change in load resistance, due to change in temperature. By varying these parameters, our output is going to be varied. And next one is voltage. How voltage regulation can be done, we will see. Voltage regulation, it may be defined as ability of power supply to maintain, it is the defined as ability of power supply circuit to maintain constant output voltage, in spite of AC input voltage fluctuations and changes in load resistance. In input voltage ante ఇది ఏసీ టైప్ ఆఫ్ ఇన్పుట్ వోల్టేజ్ అనుకుందాం. ఏసీ టైప్ ఆఫ్ ఇన్పుట్ వోల్టేజ్లో వేరియేషన్ వచ్చినా, ఫ్లక్చువేషన్ వచ్చినా సరే, it is going to give some constant output voltage. That is known as, we can treat that condition, the ability of the device is known as voltage regulation. The ability of power supply to maintain constant output voltage in spite of variation in the AC input voltage or fluctuation in the AC input voltage, changes in the load resistance. ఈ త్రీ వేరియేషన్స్ వచ్చినప్పుడు కూడా we are supposed to get constant output voltage. That is the main motto of this voltage regulation here. And percentage voltage regulation is given by V no load minus full load by V full load into 100. This is one type of formula. V no load or open circuit full load of the voltage supply by V full load into 100%. In regulation we have seen this formula. It may be note that smaller the value of voltage regulation, better is the power supply. ఈ రెగ్యులేషన్ వాల్యూ ఎంతైతే తక్కువగా ఉంటే అంత మనం పవర్ సప్లైని వోల్టేజ్ రెగ్యులేషన్ని ఎంత స్మాల్గా మెయింటైన్ చేస్తాయి. ఈ వోల్టేజ్ రెగ్యులేషన్, బై మెయింటైనింగ్ దిస్ వోల్టేజ్ రెగ్యులేషన్ యాజ్ స్మాల్ యాజ్ పాసిబుల్, then this power supply is going to be better is the power supply. Voltage regulation should be maintained as low as possible, then the power supply will be in the good condition or in the better condition. Okay, this is about what is voltage regulation means. Maintaining the ability of the power supply to maintain constant output voltage irrespective of changes in the input voltage, changes in the load resistance, changes in the temperature. Simply one line sentence we can define the voltage regulators here. And types of voltage regulators here, typically or basically the regulators are classified into two types, that is series voltage regulator, shunt voltage regulator. In our syllabus we are dealt with only shunt type of voltage regulators, so you will see this only shunt type. We are not going to see this series type of voltage regulators. Series voltage regulators means control element is connected in between input and output. Control element is connected in between input and, let it be, this is the control element. Control element is in between input and output. That means series voltage regulator means control element is connected in series. Control element is going to be connected in series. Let it be that control element is some Zener diode, like that. Control element is going to be connected in series between input and output. Whereas shunt voltage regulator means control element is connected in parallel. Control element ni ade Zener diode ni we are going to connect it in parallel here. Zener diode is going to be connected in parallel with the input and output. E control element, let us assume that it has Zener diode. That Zener diode is connected in series means we can treat that voltage regulator as series voltage regulator. If this Zener diode is connected in parallel means we can treat that voltage regulator as shunt voltage regulator. Shunt voltage and series voltage regulator. Okay, and there are many types of voltage regulators are there, but according to our syllabus we are discussing only Zener diode shunt voltage regulator. Zener diode shunt voltage regulator. There are other type of voltage regulators are also there with respect to the transistor series regulator, transistor shunt regulator, IC voltage regulators are also there. You can learn this one in the upcoming classes, don't worry. In different subjects you will come across these different types of voltage regulators. For time being, for our convenience, we are only dealt with Zener diode voltage regulator only. Okay, series, what is the difference between series voltage regulator and shunt voltage regulator means control element is connected in series means we can call that voltage regulator as series voltage regulator. If the control element is connected in parallel between input and output, I can call that voltage regulator as shunt voltage regulator. In this Zener voltage regulator we are going to discuss now. First one, Zener voltage regulator. Zener diode, this is the just a construction part. I will explain the construction part. First one is, this is the voltage supply, regulated power supply Vs, source voltage, let it be source voltage Vs, positive terminal. Everyone please respond, anyone please respond. Zener diode should be connected in, Zener diode should be connected in what bias condition? For application sake, for application sake లో జీనా డయోడ్ని ఎక్కడ మ్యాక్సిమం ఎట్లా యూస్ చేస్తామని చెప్పుకున్నాం అమ్మా? మ్యాక్సిమం ఎట్లా యూస్ చేస్తామని చెప్పాం? Anyone?
Reverse bias
Reverse
conditions.
bias. Yes, yes. In reverse bias condition, Zener diode possesses the characteristics of constant voltage. Constant voltage characteristic is there in the reverse bias condition. So I am going to use this Zener diode in the reverse bias condition only. So that's why I am connecting this Zener diode in the reverse bias condition. Cathode terminal is connected to positive and anode terminal is connected to negative. That is the meaning here. Why the circuit arrangement is taking place like this, in order to make the voltage constant here. అది రెగ్యులేట్ చేయడం కోసం, వోల్టేజ్ని రెగ్యులేట్ చేయడం కోసం I am connecting the Zener diode in reverse fashion here. Okay, this is the source voltage Vs is connected to some limiting resistor, current limiting resistor. This is Rs. Sudden flowing the current into the circuit will leads to the damage to the entire circuit. So I'm going to place one resistor here. That resistor, I can treat that resistor as current limiting resistor, that is Rs. Across Zener diode some flow of current is taking place. That flow of current across the Zener diode, it is taking place, that current is Iz. And the voltage across this Zener diode, I can treat that voltage as Vz. And flow of current is taking place across this load resistance RL is also taking place here, that I can treat that current as IL. And across this load resistance I can deduce some voltage here. That voltage, I can treat that voltage as VL here. I can treat that voltage as, this is source voltage Vs, limiting current limiting resistor Rs, and source current Is, and this GNR current Iz, load current IL, voltage across GNR diode is Vz, voltage across the load is VL, and this RL is the output or load resistance. Across output side, load resistance is maintained. Okay, this is the construction part of Zener diode shunt regulator. ఇట్లా కన్స్ట్రక్షన్ పార్ట్ చేస్తున్నాం. ఈ జీనర్ డయోడ్ని మనం ఎట్లా కనెక్ట్ చేసాం? ఈ జీనర్ డయోడ్ని వీఆర్ కనెక్టెడ్ ఇన్ ప్యారలల్. వీఆర్ కనెక్టెడ్ ఇన్ ప్యారలల్. I can treat this Zener diode are connected in parallel or shunt. ప్యారలల్గా అన్నా అంటాము, షంట్ అన్నా అంటాము. షంట్ అన్నా ప్యారలల్ అన్నా ఈక్వల్. Therefore I can treat this as Zener diode is going to be placed in shunt or parallel format. We are placing here. We are placing parallel format or shunt format. This is the Zener diode shunt voltage regulator here. If this same control element Zener diode is placed here, ఇక్కడ పెట్టారు అనుకుందాం. ఫర్ ఎగ్జాంపుల్ ఇక్కడ Zener diode పెట్టారు అనుకుందాం. అప్పుడు ఏమైంది? ఇది series voltage regulator. Control element is placed in series. Then we can treat this voltage regulator as series Zener diode series voltage regulator. Like that, we can treat this as this voltage. This control element is placed in the parallel format or shunt format. That's why I can treat this as Zener diode voltage regulator in shunt format. And this is the construction part, and we will see this one. Zener diode is connected in parallel or shunt with the load. Therefore this circuit is known as shunt voltage regulator. A resistor Rs is connected in series. A resistor Rs, this is the current limiting resistor Rs, is connected in series with the Zener diode to limit the current in this circuit. It is going to limit the flow of current into the circuit. సడన్గా ఎక్కువ కరెంట్ ఫ్లో అయిపోయింది అనుకోండి మా సర్క్యూట్లోకి. ఎక్కువ కరెంట్ ఫ్లో అయితే ఏంటంటే ఎంటైర్ సర్క్యూట్ డ్యామేజ్ అయింది అనమాట. ఆ డ్యామేజ్ జరగకుండా ఉండటం కోసం వీఆర్ గోయింగ్ టు ప్లేస్ దట్ కరెంట్ లిమిటింగ్ రెసిస్టర్ Rs across the input side. And across the output side, I am going to place some load here. That load, by variation in the load, I can make the output voltage levels can be varied with respect to that load. And for that sake I am going to place one load resistance. Input side ఒక resistance పెట్టాం, దాన్ని RS అనుకుంటున్నాం. అవుట్పుట్ సైడ్ ఇంకో రెసిస్టెన్స్ పెట్టాం, దాన్ని RL అంటాం అనమాట. అది లోడ్ రెసిస్టెన్స్ని RLగా రిప్రజెంట్ చేస్తాం. ఈ సిరీస్లో ఉంది యాజ్ వెల్ యాజ్ సోర్స్ దగ్గర ఉంది కాబట్టి ఆ రెసిస్టెన్స్ని RS అంటాం అనమాట. And the output voltage VL is taken across the load resistance RL. For proper operation, the input voltage VS must be this. For proper operation, this input voltage VS must be greater than GNR voltage. This VS should be, for proper operation, this VS should be greater than VZ here. It should be greater than VZ. This ensures that GNR operates in the reverse breakdown region లో ఆపరేట్ అవడానికి we are going to make this here. It is biased in the reverse bias condition. Reverse bias condition. This GNR diode is applying the voltage in the negative format. Therefore, this GNR diode is in the operated in reverse breakdown region. Reverse breakdown region, this GNR diode is operated. First construction part. What are the different components present in the circuit we have explained here, and making I am assuring that we are using this circuit in the reverse breakdown region. Okay. And next one, current through the limiting resistor is given by current through this IS. In order to know this IS term, I would like IS is equal to VS minus VZ by this resistance here. That is the term given here. The IS is equal to VS minus VZ by RS here, where VS is DC input voltage, VZ is GNR voltage. That is, in order to find this current IS, that is the difference between these two voltages by this resistance, that is VS minus VZ by RS is the formula. That is V by R, simply V by R. But the difference, what is the source voltage and GNR voltage, in order to obtain the resultant voltage between these two source and voltage, I am placing the voltage like this here, VS minus VZ by RS here. And ideal GNR diode acts as constant voltage source VZ. A practical GNR diode has a resistance RZ here. Ideal GNR diode acts as a constant voltage source ga acts చేస్తుంది ideal condition. In ideal condition, that GNR diode acts as a constant voltage source VZ. But in practical case, GNR diode has a built-in resistance. GNR diode కూడా కొంత built-in resistance ఉంటుందమ్మా. ఆ built-in resistance ని RZ అంటాం అనమాట. In practically, GNR diode has a resistance RZ. Due to the GNR resistance, there is a voltage drop. Voltage drop అనేది వచ్చింది అనమాట. ఆ built-in resistance, that GNR diode possesses some built-in resistance. I can treat that resistance as RZ. Then due to that RZ, some small amount of current is flowing across the GNR diode. Flow of current is taking place, and the drop, I am treating the drop as VZ. That voltage, some resistance is there across this GNR diode, some resistance is there, that is RZ. Due to this combination of current and resistance, some drop will be considered. The drop is given as IZ into RZ here. The drop is given as IZ into RZ. Voltage across the terminals of GNR diode, which is equal to load resistance. Voltage across the terminals of GNR diode, which is equal to the load resistance, that is given by IL is equal to VZ plus IZ plus RZ. అంటే ఈ లోడ్ రెసిస్టెన్స్ దగ్గర ఉన్న వోల్టేజ్, లోడ్ రెసిస్టెన్స్ voltage is given by this voltage, the voltage across the GNR diode, as well as inbuilt drop of the GNR diode, that is IZ RZ. That is the point given here. Load voltage VL is equal to VZ plus IZ RZ. If RZ is very much less than 1, then this load voltage VL is equal to VZ. That is the voltage. These two voltages are equal here. Why? Because in parallel circuits, voltages becomes same. That's why we can treat this. We can treat this as VZ is equal to VL here. And thereafter, current through the load resistance is given by IL is equal to current through this load resistance is given by IL is equal to this VL load voltage by RL here. Current through the current through the load resistance is given by IL is equal to VL by RL. Input current is the sum of GNR current and load current. That is, it is given by IS is equal to VZ plus IL. ఇక్కడ సోర్స్ దగ్గర వచ్చిన ఈ కరెంట్ ఉంది కదమ్మా, ఈ కరెంటేగా ఈ టెర్మినల్కి పాస్ అయింది, సేమ్ కరెంటేగా, సోర్స్ కరెంటే. దిస్ సోర్స్ కరెంట్ ఈ స్ప్లిట్ ఇంటూ GNR current as well as load current. That is the point given here. You can observe that one. IS is equal to IZ plus IL. దట్ ఇంప్లాయిస్ ఐజెడ్ నాకు ఈ జీఎన్ఆర్ కరెంట్ కావాలి. అప్పుడు ఏం చేస్తాం, ఐజెడ్ ఈజ్ ఈక్వల్ టు ఐఎస్ మైనస్ ఐఎల్ అని చెప్తాం అనమాట. అది బై జస్ట్ రీఅరేంజింగ్ ద టర్మ్స్, దట్స్ ఇట్. హియర్ దిస్ ఈజ్ అబౌట్ construction part, and in order to find out what is the current components, different current components present in the circuit, we know each and every how to find out this IS value, how to find out this VL value. We know this one from this basic circuit by using the KVL expressions like that. We have a simple math. We can find out the what is the VL value, what is the IL value, and what is the IS value or IZ value. Like that we can easily find out those values here. And similarly, this is the actual working, that is working of GNR diode shunt voltage regulator. We know this one, line regulation can be done. Regulation can be done in two ways here. First one is line regulation and next one is load regulation. First one is line regulation. Line means this is the input voltage. By varying the input voltage, this is the variation symbol, varying this input voltage, this output load resistance is fixed. Maintaining the output voltage as constant. Output load resistance is fixed and maintaining this load resistance fixed, and varying this input voltage. I can treat this as line here. I can treat this voltage as line voltage. Okay, line voltage. Therefore, I am supposed to obtain some constant output voltage here. I am going to obtain constant output voltage across the load. I can treat that voltage as V0 or VL here. Okay, that is the main purpose here. Line regulation can be done in two ways. First one is line regulation and second one is load regulation. Okay, first one is line regulation with varying input voltage is known as varying this input voltage. We can treat that regulation as line regulation. Consider the regulator circuit, same అదే సర్క్యూట్ తీసుకొని ఎక్స్ప్లెయిన్ చేస్తున్నాం. And consider the regulator circuit shown in figure A, that is varying input voltage. Here the load resistance RL is kept fixed. This RL is fixed and the input voltage Vs varies within the limits. Input voltage is varied within the limits. This input voltage is varied with respect to the limits or with respect to the range anamata. Different ranges are ఆ range ని బట్టి within that range we are going to operate that input voltage. And as the input voltage increases, if the input voltage increases, the input current IS also increases. Input voltage increases means this IS also increases. The increases the current through the GNR diode without affecting the load current IL. This IS get increases here. This is the point. Thereafter IS, the input voltage increases, the input current IS also increases. The increases the current through the GNR diode. IS increase చేయటం వల్ల ఏమైంది, GNR diode దగ్గర the current through the this increases the current through GNR diode without affecting the load current IL. ఈ IL ఎఫెక్ట్ చేయకుండా ఈ GNR diode దగ్గర కరెంట్ కూడా ఇంక్రీజ్ అవుతుంది without affecting this load current IL here. That is simply if Vs increases, ఇది షార్ట్ నోటేషన్లో నేను రాశానమ్మా, ఇది షార్ట్ నోటేషన్లో రాశాను, ఒకసారి చూడండి. if Vs increases, IS increases, IZ increases, but ISRS increases, this IL should be constant. This ISRS increases. This ISRS increases means this current also increases. Then IZ increases, but it is maintained. This load is maintained as constant here. This load is IS increases, VL is maintained as constant. Output voltage is maintained as constant. no effect on IL. ఆ RL కాన్స్టాంట్గా ఉంచడం వల్ల ఐఎమ్ గోయింగ్ టు అప్టైన్ సమ్ కాన్స్టాంట్ అవుట్పుట్ వోల్టేజ్ హియర్. నో ఎఫెక్ట్ ఆన్ IL హియర్. The increase in the input current will also increases the voltage drop across RS here. Increase in the input current ISని ఇంక్రీజ్ చేయడం వల్ల RS దగ్గర వోల్టేజ్ డ్రాప్ కూడా పెరుగుతుంది అన్నమాట. దేర్ బై కీపింగ్ ద లోడ్ వోల్టేజ్ VL యాజ్ కాన్స్టాంట్. ఇక్కడ ఈ ఈ ఈ విఎస్ని ఇంక్రీజ్ చేయడం వల్ల ఈ ISRS ఇంక్రీజ్ అవి ఇక్కడ డ్రాప్ పెరిగిద్ది అనమాట. ఈ డ్రాప్ పెరగటం వల్ల ఆ వోల్టేజ్ ఏమవుతుంది, ఇంక్రీజ్ ఇన్ ది ఇన్పుట్ కరెంట్ విల్ ఆల్సో ఇంక్రీజెస్ ది వోల్టేజ్ డ్రాప్ అక్రాస్ RS. ఈ RS దగ్గర వోల్టేజ్ డ్రాప్ కూడా పెరిగిద్ది అనమాట. వోల్టేజ్ డ్రాప్ అక్రాస్ RS ఆల్సో ఇంక్రీజెస్. thereby keeps the that point that voltage drop increase అవటం వల్ల across RS, thereby keeping the load voltage VL as constant. ఇక్కడ ఈ డ్రాప్ పెరగటం వల్ల ఐఎమ్ గోయింగ్ టు అబ్టైన్ సమ్ కాన్స్టాంట్ అవుట్పుట్ వోల్టేజ్ హియర్. output voltage is going to be maintained as constant because of increase in this voltage drop across this across this source resistance RS here. Okay. On the other hand, if the input voltage is decreased, if the input voltage is తగ్గిస్తే, if the input voltage is decreased, the input current also decreases. As a result of this, current through the GNR will also decreases. Consequently, the voltage drop across series resistor RS will be reduced. A voltage drop across the series resistor will be reduced. Thus, the load resistance RL and the load current IL remains constant. అది ఇంక్రీజ్ చేసినా సరే డిక్రీజ్ చేసినా సరే ఆ డ్రాప్ అక్రాస్ ది లోడ్ రెసిస్టెన్స్ ఈజ్ గోయింగ్ టు బి మెయింటైన్డ్ యాజ్ ఏ కాన్స్టాంట్ అవుట్పుట్ వోల్టేజ్ హియర్. దట్ ఈస్ విఎస్ డిక్రీజ్ చేస్తే ఐఎస్ డిక్రీజెస్, ఐజెడ్ డిక్రీజెస్. Due to this decrease in voltage drop, this drop Vs, Is, Rs drop get decreases. Due to the decrease in this voltage drop, this IL and IL and VL remains constant. This is in both the cases, though I am increasing the Vs, I am decreasing the Vs, drop across this load resistance Rs will make the output voltage as constant here. Will make the output voltage as constant. This is known as line regulation here. ఇన్పుట్ వోల్టేజ్ని ఇంక్రీజ్ చేసిన అవుట్పుట్ వోల్టేజ్ ఎట్లా వస్తుంది మనకి ఇక్కడ, కాన్స్టాంట్ అవుట్పుట్ వోల్టేజ్. మీరు ప్రాక్టికల్గా చూస్తారమ్మా ఇది ల్యాబ్ మనకి ఓపెన్ చేస్తే ఆ ల్యాబ్లో మీరు ప్రాక్టికల్గా చూస్తారు. డోంట్ వరీ అబౌట్ దిస్ లైన్ రెగ్యులేషన్ అండ్ లోడ్ రెగ్యులేషన్. మనకి ఇది ఒక ఎక్స్పెరిమెంట్ ఉంది, ఆ ఎక్స్పెరిమెంట్లో చూపిస్తాం మేము. డోంట్ వరీ, అది ఎట్లా ఏంటో అనేది ఇది థియరిటికల్గా ఇట్లా నేర్చుకోండి సరిపోయింది. Vs increasing part, this output voltage will become constant. If Vs decreases, this output voltage is going to be constant. This is about line regulation and load regulation here. Second part is load regulation. By varying regulation with varying load resistance RL, we can call this regulation as load regulation. Consider the regulator circuit as shown in same circuit I am going to consider here. But ఇప్పుడు Vs ఏం చేస్తున్నాం, ఇన్పుట్ వోల్టేజ్ is fixed here. Input voltage is fixed and load resistance RL is variable. This is the symbol. Just a minute. This is the symbol. Variable resistance is provided here. This is the fixed here, whereas this is variable. Variable is provided. Is provided here. The regulation with varying load resistance RL. Here the input voltage Vs is kept fixed, and the load resistance RL is varies. The variation of the load resistance changes the load current. This load current is going to be changed across it. When the load resistance decreases, this load resistance decreases, the load current increases. ఈ రెసిస్టెన్స్ తగ్గింది అనుకున్నామ్మా, ఈ రెసిస్టెన్స్ నార్మల్గా కరెంట్ ఇంక్రీజ్ అయితే by increasing the current resistance get decreases and vice versa. Resistance increases means current decreases, like that. In this, by using this basic notation, if this when the load resistance decreases, the current will increases. Load resistance decreases, current will increase. This causes the GNR current to decrease. ఈ లోడ్ resistance decrease అవటం వల్ల this current get increases. If this current increases, then GNR current will decreases. ఇప్పుడు ఇక్కడ ఉన్న టెర్మినల్లో ఉన్న కరెంటు ఈ టూ ఈక్వల్గా డిస్ట్రిబ్యూట్ అయింది అనుకుందాం. ఇది ఇప్పుడు హై అంటున్నాం. ఇప్పుడు ఐఎల్ దగ్గర లోడ్ దగ్గర ఉన్న కరెంటు హై అంటే ఆటోమేటికలీ GNR current will decreases. That is the point given here. And this causes the GNR current to decrease. As a result of this, the input current and the voltage drop across series resistance remains constant. That means if it is it decreases means the input voltage across this resistance, load resistance RS, the voltage drop is constant. It remains constant here. Why? Because I am applying some constant input voltage here. Therefore, those that voltage drop across series resistance remains constant. Thus, load resistance RL is also kept constant here. This RL, due to this RL, there is no variation in the input voltage. RL is get decreases initially. Initially, RL get decreases, IL get increases, then IZ decreases. If IZ decreases means IS and RS will give IS, due to the IS some voltage drop will cause across this resistance RS. That is ISRS will become constant. If this is constant, Vs is constant, then load resistance, load voltage will automatically becomes constant. That is given by VL is constant here. Similarly, next case on the other hand, if the load resistance increases, లోడ్ రెసిస్టెన్స్ని ఇంక్రీజ్ చేసాం అనుకోండి, ఇప్పుడు డిక్రీజ్ చేస్తున్న కేసు, ఇంక్రీజ్ చేస్తున్న కేసు. ఫస్ట్ లైన్ రెగ్యులేషన్లో కూడా ఫస్ట్ వోల్టేజ్ ఇంక్రీజ్ చేస్తే ఏమవుతుంది, వోల్టేజ్ డిక్రీజ్ చేస్తే ఏమవుతుంది, రెండు కేసుల్లో కూడా డ్రాప్ వీఆర్ కన్సిడరింగ్ డ్రాప్ హియర్, whereas here also drop, indirectly drop. Here ISR is constant, then VL remains constant here. Here on the other hand, load resistance increases, the the load current decreases. As a result of this, GNR current increases. This again keeps the values of input current and voltage drop across series resistance as constant. అక్కడ కాన్స్టాంట్గా ఉండటం వల్ల ఇప్పుడు ఇప్పుడు ఈ ఈ లోడ్ రెసిస్టెన్స్ ఇనిషియల్గా ఇది తక్కువగా ఉందమ్మా, ఇప్పుడు ఇంక్రీజ్ చేసాం. ఇప్పుడు ఇంక్రీజ్ చేస్తే అప్పుడు ఏమవుతుంది, దిస్ ఈస్ ఇంక్రీజ్డ్ మీన్స్ దిస్ కరెంట్ గెట్ ఇంక్రీజెస్, దెన్ జీఎన్ఆర్ కరెంట్ increases here, then this drop get increases, then due to this drop, increase in the drop, it is going to be fixed here. Therefore, I can obtain the, in the first case, in the line regulation ఎట్లా చూస్తామో, ఈ డ్రాప్ పెరిగినప్పుడు ఏమైంది, కాన్స్టాంట్ అవుట్పుట్ వోల్టేజ్ I am going to obtain. That same case I am going to apply here. Voltage drop across series resistance as constant. Therefore, the load voltage remains constant here. RL increases, IL get decreases, IZ increases. If IZ increases means indirectly IS also high value. I am going to obtain IS value is also high. IS and RS, due to this voltage drop, IS increases. Therefore, drop across this resistance, that is ISRS, is constant. Therefore, output voltage is also constant, that is VL is constant. In this way, by varying the input voltage, output voltage is maintaining as constant output voltage. By varying this input voltage, output is maintained as constant output voltage. That process is known as line regulation. And by variation this load resistance RL, that is small value and high value, this voltage, output voltage, is maintained as constant by making the input voltage supply as fixed. ఇది ఫిక్స్డ్గా ఇది వేరీ అవుతే, ఇన్పుట్ వేరీ అయితే అవుట్పుట్ దగ్గర RL is going to be fixed, and I am going to obtain constant output voltage. Here in this circuit, if Vs is input voltage is fixed, then RL is going to be varied. I am going to obtain constant output voltage. This is the difference between line regulation and load regulation. From using the same concept, some small problem is provided here. That is, find the load voltage drop across RS and the current through the GNR diode. Same circuit with some specifications. It is provided with some values here. That is Vs with 30 volts, RS is 240 volts or 240 ohms. Sorry, VZ is 12 volts, RL is 500 ohms. So like that, it is provided. Voltage drop across series resistance is given by IS. What is the first value we need to calculate is IS. We know this formula, IS value. This is the IS value. IS is given by Vs minus Vz by Rs. We know the Vs value, Rs value, Vz value. Substituting those values, I can obtain this flow of current. Is is the flow of current, that is 0.075 amperes flow of current is obtained. Voltage drop across RS. What is the voltage drop across this RS? I am going to calculate. That is ISRS. IS is calculated here. Therefore, RS is also there. By substituting those values, I can obtain voltage drop as 18 volts here. Voltage drop across this RS is 18 volts. Current through the Zener diode. Next one is current through the Zener diode. We need to calculate. For that sake, ఫస్ట్ ఈ జీనార్ డయోడ్ దగ్గర ఉన్న కరెంట్ని క్యాలిక్యులేట్ చేయాలంటున్నారు. అప్పుడు మనం ఈ లోడ్ రెసిస్టెన్స్ దగ్గర ఉన్న కరెంట్ని క్యాలిక్యులేట్ చేయాలిగా ఫస్ట్. For that sake, we are going with respect to the calculate what is the total current from the source current. Is is equal to Iz plus IL. That implies Iz is equal to Is minus IL. In order to find out this IL, we know this formula. IL is equal to VL by RL. By substituting this VL value, load voltage value, this VL value, VZ is equal to 12 volts. The same in the parallel format circuits, this voltage is equal to this GNR voltage is equal to the load voltage. The same voltage is going to be obtained. That is given here. Load voltage VL is equal to VZ is equal to 12 volts. Therefore, by substituting VL is 12 and RL is 500, after substituting, I can obtain the load current here. Similarly, current through the Zener diode can be obtained by Is is equal to Iz plus IL. By to know this value, that is Is minus IL. By substituting this Is value as well as IL value, I can obtain the Zener current here. The Zener current here. That is 0.051. 0.051 is the GNR current. That is the proper splitting of two current levels. That is across GNR diode, maximum amount of current is flowing, and across the load, low amount of somewhat low amount of current is flowing across the load. In this way, you are supposed to do some problems upon this GNR diode also. I have provided this GNR diode problems in the ఎడ్మోడోలో నేను ఆల్రెడీ ప్లేస్ చేశానమ్మా, అది చూసుకోండి. అక్కడ ఒక 3 ప్రాబ్లమ్స్ ఉంటాయి, డిఫరెంట్ ప్రాబ్లమ్స్. మీకు అసైన్మెంట్లో ఇచ్చిన ప్రాబ్లం కూడా అక్కడ ఉంటుంది, చూసుకోవచ్చు మీరు అది. ఓకేనా? ఇన్ దిస్ వే we can analyze the voltage regulators with respect to the Zener diode that is placed in the shunt format. In the shunt format, we can analyze the entire circuit with respect to the line regulation and load regulation. Okay, line regulation and load regulation. Students, again, by this topics we have completed 2 units. We have completed two units. All the topics are covered. Please go through once again. This is the second unit B part. We have seen the comparison of half wave rectifier, full wave rectifier and bridge rectifier. ఇది కంపారిజన్ ఒకసారి మళ్ళీ మీరు ప్రాక్టీస్ చేయండి అమ్మా. ఈ కంపారిజన్ ఎక్స్టర్నల్ ఎగ్జామ్లో కంపల్సరీ అడగచ్చు, ఎక్స్టర్నల్లో ఇంటర్నల్లో. నెక్స్ట్ వన్ ఈజ్ voltage regulator. Next one is shunt voltage regulator. It is going to be operated in construction of the circuit. We will explain. We have to explain construction. Thereafter, working of Zener diode shunt voltage regulator, line regulation and load regulation. By varying the input voltage, output remains constant. That output voltage remains constant. That is known as line regulation. Load regulation means by varying the load RL, though the variation is taking place, our output voltage should be remains in the constant voltage. It should provide some constant output voltage. That is the regulation part with respect to Zener diode. Okay, students.